Hello everyone, my name is Alexander Zelenin. I am experienced software engineer. Today I want to try another platform that's called leetcode.com. We will try to solve few easy problems just to see how it works, and then if you will like it, we will solve more problems here. So let me first check that everything was started. Yes, it works. So let's go with just some easy tasks just to take a look how it works. So I had not checked it before, so we'll see it like in real time. So let me just zoom in a bit. So the first one called Jewels and Stone. It's not the first one exactly, but I don't know what is the order when I sorted by like difficulty. So we have a string J representing types of stone that are jewels, and string S representing the stones you have. Each character in S is a type of stone you have. You want to know how many of the stones you have are also jewels. The letters J are guaranteed distinct, so they are unique, and all characters in J and S are letters. Letters are case sensitive, so A is considered a different type of stone from A. So we have two strings, like first one of jewels and second one of the stones we have. Since it's easy problem, it's very the solution of this will be very easy. So we will go through the J array. I think I will not draw a schema, but instead we'll just write instructions here. So I can zoom a bit more like this. So we will make we'll define a data structure for J as an object where we will have a letter like A true, and so on. So we'll have data structure, and memory complexity will be OJ exactly, since by the length of the string J. There will be no more memory consumption, so only OJ. And the complexity for the algorithm itself will be OS, since we will go through our string again only once. So memory space complexity is how many memory will be used depending on incoming variables, and space complexity is how many CPU will be used depending on incoming variables. So let's create our structure. Let's call it jewels. Do I type it properly? No. Jewels, of course, like this. So it's object. We will go through J. So let's make a cycle from 0 position until it's less than last one. Okay, I'm close to chat, so I think I can do like this. Yeah, nice. So we will just add the jewels. So jewel name, letter is JI. So, and we will just assign this jewel letter to our data structure and set true. So then we will go through our string. So we'll have the same cycle, but for our string. And we will need to count how many javels we have. So it will be very simple. We'll just take a look at current letter from S, and we'll take a look at javels object. So if javels have current letter, that means that we need to increment by 1. So we increase our counter by 1 and return our counter. Okay, let's try. So our code work well, I think. Yes. And we can submit our code. So runtime is faster than most of other submission. Memory consumption is less. I have no idea what I need to write to have. Okay, maybe I understand why it's faster in the meaning of time complexity, but what I need to do to use more memory for such task, I have no idea. Okay, so first task go very fast. Let's try with the next one. Oh, it's when it's zoomed in, it's too big. Everything is too big. So, okay, the first one is solved. Let me open its new window. Let's take a look at the next one. So, range sum of BST. Given the root node of a binary search tree, return the sum of values of all nodes with value between L and R inclusive. The binary search tree is guaranteed to have unique values. So what is binary tree? So I think the first task here is to create binary tree itself. So generally binary tree is when we have 2 more elements on every next step. So we have like root. Root have left and right. Every of these elements have 2 more elements, and so on. So like every of them have 2 paths, and like we go through this path to define something. So the lower values go to left, the higher values go to right. So if we have left 7 and right 15, we will need to first find the part where we have 7 or something greater than 7, closest one, and then we will need to find the closest with the 15. So like this. And what we need to sum here? Let's see. Sum of values of all nodes with the values between this and this. Okay. So that means that we will need to go through every node that we will have here. There might be more nodes like this one, and we will just need to make a sum of them. Let's try to understand what we have here and how it define it. So we have a root with these numbers. 5, 15, 3. So let's try to draw this one. It will be easier. So we have 10, we have 5, we have 15. Maybe let's give a bit more space. So like this: 10, 5, 15. And how this one works? So we have 4 values. Okay, 3, 7, no value, and 18. No value, it's fine, since like we are guaranteed that we have like 2 objects at each level, and we not fill the object here yet. That's all. So let me take a look just on next one. But this one is not looks like a full one, right? The binary search tree is guaranteed to have unique values. So the final value is under integer, I think. Yes. I not got yet how the incoming values represented in the tree itself, because if maybe we don't need to make a tree. We can just sum all values between these numbers. That's all. Let's try to do it like this first and check will it work or not. So I just want to go through an array. We will anyway need to do this since okay, root is tree node. So it's just a bit unclear. Is it tree node? Because here I see an array and not a tree node. Okay, we have an explanation here, so it helps a lot. Yes, we're starting with tree. We don't need to build it. And we can just go through tree and find that what we can sum here and so on. So we have left, we have right. We will starting with root. We also need to add some variable to count sum. We will do this inside. We will provide, I think it will be a recursive function. We can just provide a node as root here, our left value and the right value, and sum it up to the top. So first of all, we can add the root itself to our sum. So let's define sum as 0. If our root value is greater than left and root value is lower than right, so it's between them, we add this root to the sum. So sum, we add 1 second, root val. Okay, At the end we are returning sum, and right now we will need to go to left and to right. So we will increase sum by the same function, but root will be like left one and right one, but we will need to check first. Can we go inside or not? So to take a look that we can go to left one, we will need to see that root left value, root left value is lower than our left or right. 1 second. So if we have in this example 7 and 15, we go to left only if it's lower or equal to our left, and we go to right only if the right also lower or equal. The second one is 15, right? So we'll stop at this one. The value possible to be null also. First of all, so we check that this value is exist. So that means that it is not null. Also, we need to check is it above 0, like 0 is possible. What about negative numbers? I doesn't see any negative numbers or zeros. So let's assume for now that we doesn't have negative numbers or zeros. So if it lower or equal than L1, then we will go additionally to the left. So, and we will provide the left as our root. We'll provide left and right. Or we need to compare it with the right one. Like what if we'll have 8 here and 9 here, right? Yes, we need to compare with right value, so with our 15, to understand that it will be like under this one, and it should be no, it should be not greater than our value. No, it should be. Yes. Okay. If we have 5 here, 5 should be not added if we have 7, but we want to go inside the 5 to test all our values. So, but we have this condition here already, so we can check that we go to. I think for now it will be fine. Let me just add the second condition about right one. So right value is exist, and root right value is greater or equal than left. Then we do the same, but for the right. Let's test our code and see what we have here. Root left is null. Okay, then that means that we need to do like this. So it can be null itself, not the value, not the node, but the node itself is null. So looks like it worked fine. Let's submit our code and see how it will works. We have wrong answer, right? Okay, okay. Not a big problem. And let's try to understand what is the problem. Since we have exactly code like this, we will able to easily debug it if I understand it properly. So is it possible somehow to, yeah. So initially we have a sum of 0. We go here. 10 is between 7 and 15, right? We need to go between 7 and 15. So 7, 15. So we add 10. Then we check our value is, greater or equal, lower or equal. Maybe this one an error. Let me just check. No. We have another test case and it still doesn't work. But this one was solved properly. So this one worked fine. Let's see what we have here. We have some big tree starting with like take a look, 150. Then we have, so let me erase this one. We have 150, 150, 24, 76, 126, 176, and so on. So our output is 0 by some reason. Let's try to understand what is the problem. What is expected numbers here? So between 170 and 178. 170, 178. So that means that we should go inside here. Let me change color. Here, then we go here, and then we go here, right? And maybe we also go here and somewhere to the right. So let's take a look at our code and what it will do in that situation. So first of all, the root itself is 100. It's not greater than 170 and it's not lower, so we doesn't add anything. Let me just add a few rows to make it like this. Then we take a look at 50. 50 is lower than 178. Also, I think we can skip go to the left if it's obvious. It was obviously initially. So if like to the right of the number we have numbers only greater than or one, to the left only lower. So we can initially make a next condition. So first of all, we can leave this one, but instead of comparing to, let me also check that root exists. So like if root will be null, then we just return 0, yeah, instantly. So instead of this condition, we will take a look that if our one second. If value of root is lower than r, then we go left. Otherwise, we don't need to go left. Since, for example, if we have 100 and we have at least 100 on the left, we will not find like 101. It doesn't matter. Okay. If we won't go to the right, then our value should be the root value should be greater than L. So should be greater than left one. Otherwise, no, sorry, our so we're looking for 170. If 170 is greater than our value, then we need to go to right. So it should be different one. So if root value, what if it's if the value is between, then it should go like to both of them. Such easy problem, and I stuck a bit. But okay, that's fine. That's fine. For a long time I had not worked directly with the trees. That happened sometime. I think we anyway will able to solve this problem. And maybe one more, but okay, let's try to finalize with this one. So we have 170 in this case. And we won't go only to right. We won't go only to right because the left value is greater than current value of root. And if we will have, for example, 95 here as a left value, then we will want to go to the left by reason that the left value is lower than our current number, right? So we have a condition like this one. How we can use right here? If we have 95 and we want to go to the left, let's presume that right value will be like much greater, like this one, 178. Let me just test with this code. Because it probably that this solution, this will not work. Okay. Even I was thinking that it's green, that means that everything is fine, but it's not fine, since it doesn't mean that it's solved. Let me try with initial case one more time, since this one is very simple. So we have 10, 5, 15, 3, 7, nothing, and 18. And we have two numbers, 7 and 15. So we have 7 and 15. First, what we check, that our root is between both of them. Yes, it's between. Then we check that our value is greater than 7. Yes, it's greater than 7. We go to 5. Also, we check that our value is lower than right. Why I write it like this? My God. I think I had write initially like, yes. Initially I had write it properly, but then by some reason I start comparing with something else. So we have like fast enough solution. We have low memory usage, since there is memory usage only for the one variable. So let's calculate space and time complexity, what we have here. We have some binary tree. Binary tree guarantee us that we like have complexity of going to the root of log n. Okay, that's like by definition. So go to n will be log n. So in the worst case scenario, we will need to go through all the elements. So for example, we'll have 3 like this one, and we will have numbers like 0 and 20. So we'll go up to this one, and go to like every root. We will do summarize and so on. So in worst case, the time complexity will be O(n). Not root, O(n) will be more proper one, since we worrying only about how many nodes total we have in root. And for space complexity it will be O(1). Okay, sounds good. Like I have couple of errors by reason of I doesn't understand the test output, that it was like successful or what it was here, but originally it was not. So okay, we had solved the second task, and let maybe try to do some third one. So let me just update this page to see this one is solved. Yes, 2 of them solved. Let's go to see some anagram mappings. So we have about 10 minutes, and let's just take a look what we have here and define will we be on time or not. So we have 2 lists, A and B is anagram of A. So the B have same letters. Anagram means that it has same letters. B is made by randomizing the order of elements of A. We want to find an index mapping P from A to B. So we want to find like every letter. Okay. These lists A and B may contain duplicates. If there are multiple answers, output any of them. For example, we have like this one. So instead of letters, is it letters? It's lists. Okay, so we have two arrays of numbers, and we should return the index of every of them in the second array. So we found 12. We need to return 12. We're looking for 28. This is last one, so we just return indexes of these values. The first obvious solution is to go through every letter, try to find it in an array, and then remove it from this array and just use index. So let's try with a super fast solution that we can do in JavaScript. There is a function index of to find some value. We will use this function to build this array. So let's make an array, not answer, but how it called, order, pairs, mapping. Mapping is good name. So we have mapping array. We will go through every letter in A from the first letter until the last one. And we will find an element in array B. So B index of, let me save also current letter. Current letter will be AI. Current letter. So we found an index in B. Index. And what we do next is we push this index to mapping. And the second thing, since we already had found this, we will modify array B by removing this element. We not exactly removing, but replacing it with null, so we will not found it second time. And we will return mapping. I doesn't like this algorithm. I will explain a bit later. Let's try to run our code, and this time pay attention to output and expected one. Looks like it's the same. And submit our judging. It's 100% faster. How it was possible? I'm not sure that these numbers are correct at all. So, but okay, we had solved this problem. It was much easier than previous one. Previous one was also easy, but only when you remember how to work with trees. So next time when we face trees, it will be much faster, since like I already remember how to work with them. So let's take a look what space and time complexity we have. So first of all, space complexity and time complexity. For space complexity, we have only one object here, which is mapping, right? It doesn't store anything else, and size of mapping will be the same to count of letters in any of them. So it will be like OA length. For time complexity, first of all, we go through an array A, and then we using index of. And like in the worst case, since it's not ordered array, we doesn't have any kind of index here, it will took OM for OB length for every of letter, and it will happen OA length time. So we have totally time complexity of OA to B. We can move from this to something like A plus B. Let's do this. We have a few minutes left, so I think we will be in time. To do this, we can prepare something like an index for the object B. So let's do something like that. I want to create an object that will represent letters, like not the letters but these indexes. For example, it will be like 12. We will have something like count that will represent how many of them we have here. So for example 1, and indexes will be an array of the indexes. So for example, like 1, 5, and so on. We will reduce this counter, and we will increase and we will go for next value in our indexes. So the task is to build that index that we will able to go through. So let's do this. We will go through. Hotcase here is not working. In HackerRank we have hotcase like Ctrl D to select the same values, and here we doesn't have hotcase. But what is good that we doesn't have any additional code, and we only need to build only our function, which is nice. So we have current letter. It's not letter, sorry. Just let it be current value or whatever. We have some structure. Let it called like this. Originally it should be called like index, since it's like index for search, but fine. So if we doesn't have structure current, then we will create this. We will create this object. We will have count of 0, and indexes will be empty array. After this, we will increase current count by 1, and we will push to our indexes or value of I, or I, since it's our current index. So instead of searching here, we will do something like that. First of all, we sure that this value exists, like its guarantee exists, and all of them have pairs and so on, since it's anagram. So we don't need to check that it exists, it's guaranteed. So we just need to fill our mapping with values. We will go to current one, we will go to indexes, and number of indexes will be like the count minus 1. Okay, and after this we will remove 1 from this count. I will try to explain a bit later. Let's just try to run our code and see is it work or not. Because if it doesn't work, it doesn't matter anything. So on we have error over here. Let's try to understand what is the error here. Count of undefined. If it doesn't exist. Okay, I miss the letter. Like, we need to check create structure only if it not exist. If it exists, we don't need to do anything, of course. So our output is the same, and let's try code one more time. What I found funny here, that this time our solution is slower. And I just want to compare one more time. Sorry. We have comparison here. So runtime is greater than the previous one, but originally I just presume that there is not enough test cases to test it well. Let me explain what we have achieved by this structure and this modification. We achieve better time complexity, so we move from a multiply b to a plus b, which is much better. So for example, if we have 100 and 100, we have like 10,000. But in this case, we have just 200, which is significantly lesser than 10,000. For space complexity, yes, we add like new structure that represent every letter from B as an object like this with indexes and so on. In worst case, all the symbols is unique. So we have again A plus B for the space complexity. So amount of memory was increased, but like in the end we got much better time complexity and like it's more balanced. So we built such structure just once by going through B array just once, and then we just going one by one, getting one element from index, like next letter, next letter, next letter, and so on. So like we just going once and we don't need to parse a string, use some heavy functions and so on. So like complexity of this cycle will be just an A. So because we're just going through A and we add one element to an array. Okay, so today we had solve 3 tasks. That was easy ones, but just for testing platform, that's good, I think. So if you want me to try to more leetcode, to maybe in future try some like mock interviews, like Google one, Facebook one, other ones, and so on, set like, subscribe, comment what you want to change, what is possible to improve on these videos. Thank you for watching and have a nice day.